Hello, geometry class. Hopefully you remember tangents and circles because we're going to pick up right where we left off. I've put a copy of the blank notes in Classroom if you want to print it up and add to it as I go along, or you can put it in your notebook, however you want to do it. Okay. So example 1, SR is tangent to circle P and circle Q. So if it's called circle P, it means that P is the center, circle Q, Q is the center. It's telling us that QT equals 6, so I'm going to label it. TR equals 8, and PR equals 30. Okay. Hopefully you remember, before we left, that if you have a line tangent to the circle, that means it meets the segment in 90 degrees. And these segments here, so QT and PS, those are radii, because they go from the center to the edge. Now, look here. I'm going to outline my circle, or my triangles. And I have a little triangle here, a right triangle, and a bigger triangle here. So I need to remember properties of similar triangles and the Pythagorean theorem to solve this problem. Well, here, if I can find QR, then I can find PQ, because I know what the whole segment is. I can take away the piece. Very nicely, it's a right triangle, but it's also one of our Pythagorean triples because it's a 3, 4, 5. This is 3 times 2, 4 times 2, so this must be 5 times 2. If you didn't recognize that it was a triple, you could always do Pythagorean theorem. So if this is 10, then this must be 20 because the whole thing is 30. So I've answered the first part. Okay. Now I'm going to look at PS. All right, I don't know what PS is. I'm going to assign it a variable. I'm going to call it X. Oh, and it looks like I have some similar triangles there that I can set up proportions for. So that's what I'm going to do. So to solve for PS, I'm going to write I'll start with one ratio. And I know that the bottom of this small triangle must be a ratio with X, right? And then I can write the proportion. So if the smaller to the larger, then I'm going to look at the hypotenuse. Okay? I'm going to take the hypotenuse of the smaller one and compare it to the hypotenuse of the bigger one. All right, cross multiply. You get 180 equals 10x divided by 10. X must be 18. There we go. And now I can put that 18 there. ST, I'm going to assign a different variable to. We'll call it Y. And again, I'm going to write a proportion using two ratios. There's more than one proportion I can write, but if you're comparing part of the the correct corresponding parts of the smaller to the corresponding parts of the bigger, you'll be fine. So to find ST, I'm going to see if I have the leg of the big one, that's 8 plus y, compared to the other leg of the big one, I can write a proportion with this leg of the smaller one and the other leg of the smaller one. Okay, again, there's more than one proportion you can use. This is the one I'm going to use. Cross multiply, and I get 48 plus 6y equals 144. Isolate y by subtracting 48. I get 6y equals 96. Divide by 6. X equals 16. And we found all the missing pieces. Let's move down to number 2. All right, JK is tangent to circle P and circle Q. We want to find the length of JK. And it says, hint, what kind of a quadrilateral is JPQK? So I'm going to draw on the segments here. I can move to make the quadrilateral. And it looks like it is a trapezoid because I could prove that these are parallel because they must meet at 90 degrees. And I'm also going to draw another quadrilateral because I'll draw the height, but it also will end up being a side of something else. Okay, so here's my height. And this, it's an altitude, so it must cross at 90 degrees. Now let's see what pieces I can fill in. This segment here is a radius because it goes from the center to the end, or the edge of the circle. So QK must be a radius because it does the same thing. So this must be 3. 11 is the radius of this one because it goes from the center to the edge. So this whole piece must be 11. All right. Now, this segment, if these are both 90, this must be a rectangle, right? Because I know this is 90. This would have to be 90. So if this is 3, that is 3, which means this piece is 8 because it's 11 minus 3. Now I can use the Pythagorean theorem to solve. Right? So I want to find this piece, because if I can find this piece, I can find JK. So if I do 11 plus 3, I get 17. So I have 8 squared plus x squared equals 17 squared. Now this is also one of our triples, but I'm going to go ahead. You may not recognize it. I'm going to use the Pythagorean theorem. 64 plus x squared equals 289. Subtract 64 from both sides. X squared equals 225. You could always use the square root key in your calculator, but hopefully you remember that the square root of 225 is 15. So if this is 15, this must be 15. Good. All right, next page. All right, so here we have when 3 or more tangents to a circle form a polygon, a figure like triangle ABC or quadrilateral like on the last one, JKALM, is formed. If the lengths of the sides of the polygon are known, then the lengths of the tangent segments can be found using simple algebra. Because of an old problem involving an explorer walking around a circular region on a polygonal path, these are called walk-around problems. It's actually a thing. I posted a video, another YouTube video about walk-arounds in case you need further explanation. AB, it tells us, so we have a 3-sided fence, ABC, and it's tangent to a silo at M, N, and P. A silo, in case you don't know, is usually found on a farm, and it holds feed for the animals. So AB is 20, BC is 32, and AC is 26. Find the lengths of the tangent segments. Now it's called a walk around because you start at one place and go around the circle until you can name or give an expression to each segment. So hopefully you remember that if these lines are tangent, then an A is a point, it's equidistant from these tangents to the circle. So these must be congruent. And if those are congruent, then this must be congruent to that because they are equidistant from C. This must be congruent to that because the two segments are equidistant from B to the sides. So if I'm going to start here, these two X, then MC must be 26 minus X. These two are congruent, so this also must be 26 minus X. BN and BP are congruent, and I have 20 and X here, so I'm going to call this 20 minus X, and this 20 minus X. Okay, I'm going to use this information down here because I have two different numbers. I have X, but I have two different numbers, and that's going to help me solve for X. These wouldn't be so helpful. So I'm going to set up my equation. So I know that 20 minus X plus 26 minus X must equal the whole, 32. I'm going to combine like terms. And I get 46 minus 2X equals 32. Minus 2X, subtract 46 from both sides, equals negative 14. x equals 7. So I have that x equals 7 that I can fill in all the blanks for all the segments now. So that means that AP is congruent to AM, and that is 7 because we said that was x. We have MC equal to NC. That's going to be 26 minus 7. Oh, let me move my camera. And that's going to be 19. Now I have BN, which is congruent to BP, which is 20 minus 7, 13, not 17. There we go. All right, so we've found values for all of the segments. All right, our last one. Let's label what we have. If JK equals 22, KL equals 15, LM is 13, what is the value of JM? Now to solve this, it would probably be helpful if you knew that when you have a circle circumscribed about a quadrilateral, actually I would say within a quadrilateral, that means that the sum of the opposite sides are congruent. That's the opposite sides of the quadrilateral. So while it looked like it might be a tough one to solve at first, we're just going to do a pretty basic equation, I'd say. If I call JM x, so the opposite sides, so 22 plus 13 must be equal to 15 plus x. Not so bad. 35 equals 15 plus x. Subtract 15 from both sides and you get x equals 20. So that is the value of JM. All right. That's it for our notes today. For the rest of your time, there are some problems assigned to you from the book. They're posted in Classroom. They are also they're on the homework website, but I'll post each day what the homework problems are, or the rest of the classwork problems. So it's page 645 through 647, numbers 29 through 33, 38, 41, and 42. I hope you're all doing well, and I'll see you tomorrow.